Hello, class, and welcome to section 3, lab 3. This is the lab that will be covering Avogadro's hypothesis. And so Avogadro hypothesis states that equal volumes of gases at the same temperature and pressure contain an equal number of particles. Okay, and so I'll write that right here. So equal volumes of gases at the same temperature and pressure contain the same number of molecules. Okay, and so this is because according to kinetic molecular theory, since the space between gas particles is so large that we consider the individual gas particles volume to be negligible, and so the actual size and shape of the gas particle doesn't really matter. We just treat them as small discrete points. All right, and so at standard temperature and pressure, okay, so which is 1 atmosphere and 273 K, 273 degrees Kelvin, 22.4 liters of gas contains 1 mole of molecules. Okay, and as we discussed in class, 1 mole of molecules is actually equal to 6.02 times 10 to the 23rd particles or molecules. Okay, so if you have 1 mole of something, that means you have 6.02 times 10 to the 23rd molecules of that substance. Okay, and so the reason why this is important is because a mole of gas will have a mass equal to the substance's gram formula mass. Okay, and so since that's the case, we can use this then to figure out the density of our gas at STP. So density at STP will equal the mass, which is our gram formula mass, over our volume of that gas when it is our volume of 1 mole of that gas, which would be 22.4 liters. However, in table S, we use milliliters, so I'm going to multiply that value by 1,000. So it's actually 22,400 milliliters. Okay, and so we can use this this observation to figure out the density of different gases. Okay, and so let's consider two balloons of gases, both at the same volume and both at standard temperature and pressure. Okay, so we're going to say they both have a pressure of 1 atmosphere. Okay, and they both are at a temperature of 273 degrees Kelvin. Okay. Okay, and we'll also say that both of them have a volume of 22.4 liters. Okay, and so if that's the case, then we can say that both balloons contain the same number of particles. All right. And in fact, they both contain precisely 1 mole of particles in this scenario. So now, just going off of the observations we've had from real life, we know that both of these balloons, the one filled with helium and the one filled with CO2, they're both going to act very differently. Okay, so a helium balloon will actually float and rise to the ceiling, and a carbon dioxide balloon, or a balloon blown up manually, will sink and fall to the floor. And so the reason why, even though both of them have 1 mole of particles, each mole has a different mass, because each particle has a different mass. Okay, so if we look at the gram formula mass for helium, since it's a monatomic element, we just look at the atomic mass for helium and convert it to grams. And so the 1 mole of helium gas has a mass of 4 grams. Okay, but if we look at the gram formula mass for CO2, since we have 2 oxygens and 1 carbon, so 16 plus 16 plus 12, we actually have a gram formula mass of carbon dioxide that's equal to 44 grams, okay, which is much larger. So now we can use the relationship that 1 mole of gas has a volume of 22.4 liters to figure out the density. Okay, so we can say the density of our helium gas is equal to 4.0 grams divided by 22,400 milliliters. Okay. And that'll actually be equal to 0.00018 grams per milliliter or centimeter cubed, either one. And now this value for helium is actually in table S, so you can look this up, but we just calculated it right here. Okay, now if we calculate the density of CO2, we have 44 grams per mole, and 1 mole of any gas at STP is going to be 22,400 milliliters. And so we find that this has a density of 0.0020 grams per milliliter. Okay, so the density is much higher for CO2 gas because each particle has more mass, even though both balloons have the same number of particles contained within them. Okay, and so just a quick review: equal volumes of gases at the same temperature and pressure contain equal number of particles. Okay, and 1 mole of gas at STP contains 1 has a volume of 22.4 liters, okay? And we can use that to figure out the density of gases. And since each particle has different masses, these gases will have different densities, okay? And so that is our lesson for today, and I will see you for lesson 4. Thank you.